I think some of you may know who I am. My name's Innes. I'm one of the senior consultants here at IO Associates. I sort of cover the Java market in the Southwest. And we've also got B, who's also hosting. Do you want to say a few words?
Yeah, hi guys. I think again a lot of familiar names, but a couple of new ones as well. So yeah, nice to meet you all. I head up our contract team. Again, focusing on Java. It was predominantly in the Southwest, but obviously since COVID, I'm covering everywhere, as was the story for a lot of us. Yeah, so you can see our little pictures. If anyone wants to hover their phones over our little QWERTY things with the dinosaurs, I think it's supposed to take you straight to our LinkedIns. Whether or not it works, I'm not too sure, but that's what we've been told. So yeah, nice to have you all. We're lucky enough to obviously have Jason from Starling Bank here doing a talk for us this evening. Yeah, Jason, over to you, I guess.
Yeah, hi. So hopefully I should be able to share my screen.
I'll stop sharing mine.
Yep.
You should be able to do yours.
Okay. Let's hope that this works. Oh, really?
Live television.
Yeah, you know, never do live demos. Right. Okay. In order to change my preferences, I will be back. I have to change my preferences, but I have to quit Zoom in order to do that because something. Right. So I will be back in a second.
I'll see you soon. See you soon. Well, thanks everyone for coming.
Well, at least he's human. Right?
Oh, he's back.
Any jokes in this?
Right, there we go. Now, like this time around.
I think I need to make you co-host again, don't I? Hold on 2 ticks.
Right. Hopefully you can see that.
Yes.
Can you see the slide, a title slide? Can you see a title slide?
Yep.
Yep, good. Cool, fantastic. Right. Okay, so hi, let's start this again. My name is Jason Maude and I am the Chief Technology Advocate at Starling Bank. So what do I do? I joined Starling Bank about 4 years ago as a senior engineer working on the back end. The first. Sorry, I'm getting a bit of feedback. Could someone mute whoever's? There we go. It's gone. So the first thing I was asked to do at Starling Bank is I was told that the bank didn't have a direct debit system. Could I please write one? So that shows you how little code there was at the time. So I was tasked to write the direct debit system. Progressed on from there, worked on many different aspects of the system as it got built up and up and up at Starling Bank over the past 4.5 years or so. And then I moved into technology advocacy. Which is basically going around talking about the bank to various different people, different groups of people about the technology behind the bank and our technology philosophy. And this is a talk that I have given a number of times, but I haven't given in a while. Many of my talks these days appear to be about, to more industry people. So it's nice to be talking at a sort of more technical level again, rather than a high level trying to convince people that, agile is good or what have you, and fairly generic topics like that. So I'm glad to be talking today about the architecture of our software and some of the architectural principles behind it and why we have them and why these are needed to promote ultra high reliability. So right, let's start off with talking about banking and IT. I don't know how many of you who are in the call work in IT, specifically in finance, but you'll probably know that finance, when it comes to most things, is quite conservative with a small c. It's quite it fears change in a way. It likes to be cautious and careful. And there's good reason for that, right? We're dealing with people's money. This here is a quote from, of course, Mark Zuckerberg: "Move fast and break things. Unless you are breaking stuff, you are not moving fast enough." And for a while, this was the unofficial motto of Facebook. Now, what Mr. Zuckerberg was trying to say here was not that you should break things or that breaking things is good. What he was trying to say is that sometimes you have to deploy code before it is absolutely 100% ready, but you might not have ironed out all the kinks, you might not have got everything exactly right and exactly as it should be, but by deploying code, by putting it out in front of real customers, you get information back about how you are, what you are doing and what's good and what's working and that sort of thing. And that is more valuable in software, getting information from real users about how they use the software than making sure the software is 100% exactly reliable and so on. So move fast, break things. That's the sort of philosophy of the the tech industry, and definitely the new internet businesses and that sort of thing. But that wasn't really the banking way. Banking and finance didn't like that because they were concerned about security. And here is a quote from Harry Potter to illustrate that. It's banking is about security. It's about keeping things safe, about keeping money safe. You have to keep the money safe because if you don't keep the money safe, people stop trusting your bank. And then if people stop trusting your bank, what happens is what happens in one scene in Mary Poppins, or in real life to Northern Rock, the bank, if anyone remembers them, in 2007, when everyone sort of floods towards the bank to try and get their money out at once, and the bank collapses. If you lose trust as a bank, you lose the bank. So banking and finance was very suspicious of this move fast and break things type of thing. And we're like, no, we don't like that. We're going to go slowly and carefully and so on. So you had this dichotomy set up that you could, on the one hand, you could be fast and speedy and like Facebook or Google or Amazon and so on, or you could be safe, secure and reliable like the banks. Those were the two paradigms, and you had to have one or the other. That was the sort of prevailing wisdom for quite some time. So here's the story. In 2012, there was a large bank which was doing a release of code. It was doing a release to a batch job scheduler, which was a piece of code that scheduled batch jobs overnight, basically. They made the change and they monitored it overnight, and they were not too certain about the results. The results seemed to be poor, right? They seemed to be, the performance was down, things were taking longer than expected and so on. So they sat around and they consulted, and they had, they brought in a lot of different people and, gathered them round and said, well, what do we do? And it was eventually decided that what they would do is they would roll back, right? The rollback turned the minor inconvenience of a release that didn't quite work into a complete catastrophe, because while they successfully rolled back the code, they didn't roll back their database configuration changes. And what that meant is that all of the database entries telling them which jobs to schedule when were completely out of line with what jobs were actually in the code and what the code expected. And this complete mismatch meant that the batch job scheduler was merrily scheduling jobs without a care in the world as to whether those jobs were actually correct to schedule or whether the data was actually in place that needed to be in place to be scheduled. It merrily just plowed on, destroying data as it went. And boy, did it do a number on that data. It took months, this major high street bank, well-known household name, months to unravel all of the chaos that this caused to people's accounts, to their mortgages, to their balances, and so on and so on and so on. This bank was not moving fast, it was moving slow. It was moving slowly, cautiously. It had planned this release for months and months and months. It was monitoring it carefully. It did the release overnight. It was very slow, deliberate, and cautious. It moved slowly and it broke things. So if you move fast, you break things. If you move slow, you break things. If you develop, you break things. Developing code means that you will break things. Things will go wrong. And once you accept that idea, once you say, well, we're going to break things anyway, things are going to go wrong, how can we minimize the impact of things going wrong? Then you can develop very resilient code. Not only that, you can develop very resilient code that allows you to move fast and be secure and reliable at the same time, not one or the other, but both at once. And that is what Starling Bank has tried to do. So our philosophy started out as being, we are going to break things. Things are going to go wrong. How do we stop them going wrong? Because that's impossible. You can't stop everything going wrong. But how do we make sure that the impact to customers is as small as it possibly can be? So we're now going to delve into the architecture. How do you make your architecture ultra high reliability even when things are definitely going to go wrong, because they always do with software, especially if you try and change it. So the first point to realize is that when you're dealing with distributed architectures, when you're dealing with like microservices or things like microservice architecture, or even what we have, which we don't really call microservices, we more term them microliths. The question of how big is a microservice is an interesting one that we can debate about. But when you're dealing with these distributed architectures, the resilience problem, as we have learned from the example of that 2012 disaster that I just talked about, generally comes from a situation where a bug in one system gets passed over to another system and another system and another system, and the bug propagates throughout the different services. And the reason that this mistake is allowed to propagate is because the systems trust each other, right? So that when they receive a command to, say, make a payment or move some money about one place to another or change someone's name or address or what have you, oftentimes they just do it without thinking. If the command came from somewhere trusted, i.e. another node on their trusted network, then they will say, sure, I'll carry out the problem. I'll carry out the command, which turns out to be a problem, right? So they carry out this problematic command. So how do we make sure that that doesn't work? Well, that doesn't happen. That when a problem occurs in one place, it's limited to one place. We limit the blast radius, the impact of the problem occurring. This is where we come on to the idea of self-contained systems, which was the sort of starting point where, the idea that we started from. Now, I'm not going to go through the self-contained systems ideas or, in totality, but in brief, the idea is that each system has control of its own world, basically. So we divide the systems up into domains that are sort of sensible domains for a particular concern that the bank has. So, for example, we have a system that deals with cards. So cards and card payments. In fact, we have that's separate now. So we have one that deals with cards, printing cards out, sending them out to people, and that sort of thing, physical debit cards, and another system that deals with card payments coming in and being, processed and shuffled through the system off into the correct place. So those are two systems. We also have a system that connects to the faster payment network. that allows you to make bank transfers. We have another system that deals with, monitoring and recording balances, one that deals with customers' personal details, and so on and so on. So we have lots of these different systems, each of which has their own individual domain, their own individual database that they control, their own set of APIs, which allow them to connect to either other systems in the back end, or to systems in the front end, or out to the internet in general, depending on what they need. So all of these services are responsible for their own little world, and responsible in the sense that when they get instructions through, they treat those instructions with a degree of skepticism. They check those instructions to make sure that they are correct, to make sure that they are good to go. So here's a vague diagrammatic representation of that. So we've got the little boxes here representing the various systems which can talk to each other. Each one of them has their own database that they connect to, and those they will be contacted by maybe the mobile app, possibly the management portal, which is our browser based system for the managers of the bank to manage the bank and so on, and get information out about each of the bank users. It might be contacted by our public APIs that various different people can contact. That might be contacted by the browser-based system we have called the Internet Bank, which is our browser-based offering that people can connect to instead of via the mobile phone. So those are all different, possible ways that you can, that these systems will contact each other and the outside world. Now, each system is running at the moment is running in there'll be multiple instances of each system running. They'll all be running in EC2 instances on the cloud, on AWS. And there'll be a load balancer that will make sure that there's the correct number of instances running at any one time, which is usually 3, but it might be more for certain particular things. Like the balance controlling service will have more of those instances running, for example, because it's under heavier load, and will raise and lower the number of instances as necessary. We are gradually migrating the system to Kubernetes for various reasons, one of them being so that we can be cloud agnostic more easily, and end our sole dependence on AWS as our only cloud provider. But the same sort of principle will apply. These will then be running in in the cube somewhere. I need to brush up on my Kubernetes before we move over to that. Okay, so we invented a brilliant acronym to describe this system, which you can see up on screen. Just rolls off the tongue to describe this architecture, which was lots of autonomous systems continuously trying to do idempotent things to each other, or losci aditio. Very simple, very easy to remember. And then we realized that was a bit of a mouthful, so we decided to shorten it to simply ditto architecture. Do idempotent things to others. This is the concept. That the main idea behind ditto architecture is this one shown in this circle down on the bottom left. Everything must happen at least once and at most once, right? So whenever a person asks for a payment to be made, the payment must be made at least once, and it must be made at most once. Now, you might be asking yourself, well, why didn't you just say once, Jason? Surely that would have been a simpler way of saying that. I agree, but saying it at least once and at most once highlights the 2 failure cases that you have to cope with, and brings you back to that idea that things will go wrong. How can you minimize the impact when they do? Doing things at least once means that if someone asks for a payment, you don't want the payment not to be made. You don't want to say, yep, we've accepted your payment, assuming they've entered all the correct details and they have enough money to make the payment. Brilliant, payment is made, and then not make the payment. You don't want to do that. That'll lose you trust very quickly. Nor do you want to say, sure, we'll send your £20 across and instead send £60 across as you send the payment across 30 times. And there's the Idem potency for you. You need to make sure that if the request accidentally gets made 3 times, that the effect is the same as making it once. And that is the Idem potency in action. The services, each of our self-contained systems, must be smart, independent, and skeptical. So they must mistrust commands coming from the outside world. They must check and recheck and say, has this actually been done? Has this been done already? And so on. And it must have the independent control to be able to do that itself in its own domain. And that's how we stop the spread of errors that you often see in, where you have various different systems interacting with each other if they trust each other too much. The systems overall must work then towards eventual consistency, must work towards being consistent at some point. If they are not immediately consistent, they must at least work towards being in a consistent state as soon as they can. So let's go through this and in detail in action to see how this works. So let's say we are trying to make a payment. So someone picks up their mobile phone and they type in, I'd like to send £20, please. I type in £20, I'll send to this bank account over here, and I click and it accepts the action. This then gets sent to, let's say, the customer service, which is the service that maintains my list of payees for me who I want to pay and that sort of thing, and the payments I want to make to them. And it says, great, I have acknowledged that. Thank you very much. And all it does is it does the minimum level of validation required, and then it saves the payment in the database, puts it in the database and says, here is a payment that needs to be made. And it adds it to a queue. Now, a queue, we have our own queuing system, which we've written ourselves. One of the big things that we wanted to make sure is that the smarts of our system were in the services, not in the pipes between them. So the pipes between the services are fairly dumb. We've got REST APIs everywhere. There isn't any storage of data or of items or workload or anything like that in the pipes between the service. All of the smarts, the cleverness is in the service itself, and the work that needs to be done is stored in the database for that service. So you post a payment to customer and say, I'd like to do this, please, and it goes, thank you, acknowledged, I've saved it in the database, done. Asynchronously then, it then says, let's move that payment and let's take that payment and send it off to the payment service, which is the service that connects to the faster payments network. And it says, I'd like to send out this payment, please. And payment comes back and goes, very well, accepted, thank you very much, saves it in the database, its database, and then asynchronously sends that payment out to the faster payments network. Now, we also have to record that in the ledger, and the ledger is saved in a place called Bank, in a service called Bank. So we then go to Bank and say, please put this in the ledger to record that we owe some money to the faster payment service for sending out that payment for us. And Bank goes, very well, I will write that in the ledger. Done, thank you very much. And that was all very easy and nice and simple, but of course, that was the happy path. That was the path if nothing goes wrong. But life doesn't always work like that. So what happens when things do go wrong? So same scenario again. We try and make the payment. Customer then tries to contact payment and says, I'd like to make a payment, please, and gets no response. Nothing happens. So the payment has to be made at least once. And the fact that we've got no response from payment means that it probably hasn't done it. So the instance has to say, well, it hasn't done it, so I'm going to wait a little bit, and then I'm going to try again. And it has to have this retry mechanism. It keeps trying the command over and over again. The queue system we've set up automatically retries with an exponential back off every single command. So it will very quickly try again. And let's say this time it gets through, it goes great, fantastic. And if it doesn't get through, it waits again a little longer this time, and so on and so on and so on. And it keeps retrying over and over again until it manages to get the payment through. Now let's imagine the opposite scenario. We try and send the payment to from payment to bank to record it into the ledger. Now this time the payment gets through, but the response gets lost. Maybe the instance that sent through the payment gets terminated after it's sent the request, but before it's received the response. So now payment doesn't know whether bank has got the message or not, but bank has got the message. So payment's going to try again. It's going to try and say, bank, you need to record this payment in the ledger. And bank needs to remember that it has recorded it in the ledger. So it needs to have some way of uniquely identifying the payment. And that's why this UID is passed around everywhere. Everything in the system has a UID, you know, all of the everything, payments, people, addresses, direct debit mandates, everything, every single thing has a UID stamped on it somewhere. And that is so that we can uniquely identify it when we are passing it around the system, so that we can make sure that if we need to do some processing on it, we know whether we have done that processing or not. Right, so that's the overall architecture, and that is the Ditto architecture principle is across the system. Everything everywhere has this principle baked in. It has the principle that everything will be retried until it is confirmed successful, and everything will be idempotently checked. So every single time something is carried out, there might be the possibility that it will happen more than one time, and we have to be able to handle that and only process it once. So what are the benefits of that? Given that we've got that system in place, and we've tried to minimize the impact of things going wrong, what are the benefits? Well, there is one key one, which is not that slide. Instance termination is safe. That is the key thing. So you can take an instance of anything, any of the services. You can terminate it whenever you like, and it'll be fine, right? Because if it was in the middle of doing something, that's fine, because the system will retry the thing it was in the middle of doing. It won't have assumed that it has completed. It will retry it, and if it did mostly complete it, it won't, it won't retry the bits that it already has done, or it'll, check that it's done them and say, no, they're fine, they're already done. So instance termination is safe. So you can safely click off an instance and it'll be gone, and then another instance will come back up and carry on processing. Now, the benefits of that are very, very large indeed. The first thing it means is that we can deliver speedily. We can deliver very quickly. We can deliver at scale. So this idea that we can either move fast or be secure and reliable, and you have to choose one of the other, is gone now. We can have both. We can move quickly because we can do a release one day and go, I'm going to put out some code, done. And we can do that release by taking all the instances down of the thing we're releasing and bringing new instances of a new version back up again, without worrying that it was in the middle of processing something. Because if it was in the middle of processing something, that will just be caught up by the system in a safe and reliable manner. So it delivers both at the same time. We have, in order to speed this up even more, we have automated using Slack a lot of the process by which we do the release. We will post, we are doing a release of these commits. Here are the commits that we are doing. All the commits have been approved. We go through and check them, and then we say, right, we're staging the release. We automatically, push new images that we want to deploy, and then eventually someone goes into the Cloud Console hits the button, then deploys the new images, and we take the old instances down and bring new instances up. And that's all safe. And we do that in the middle of the day. And we do all our releases in the middle of the day. It's very unusual for us to do one out of hours. So we don't have to do that thing that many banks do of going, hey, it's, it's 2 a.m. to 5 a.m. this Sunday, your bank will be switched off because, they have to do a deployment. So they have to take the system down because they can't cope with a command being put through halfway through a release. Whereas we can, because, either the command will be saved or you'll just get a message going, whoops, there was an error, press again. We won't do a thing where we say, yep, we've accepted it, and then not do anything with it, because the system will ensure that doesn't happen. So this sort of like, hey, let's do a, one release every 3 months and 2 a.m. Resulted in what was called this bimodal IT structure for banking. And what that meant was, because the backend was only deployable very, very slowly and on a 3 month, 6 month, year-long cycle, then you got these sort of blips, and then you got the mobile over the top of it, the mobile UI layer, which could deploy faster because it was more modern and more able to accept changes, moved quite quickly. So you got this mobile struggling over a unmoving back end and trying to make the best of what they got in the background. Whereas at Starling, it looks more like this. The back end is released all the time, whereas the mobile and other front end architectures are released once every so often. The reason we do that is we don't want to bombard people with daily changes to their mobile apps or things like that. Whereas the back end, we can release as often as we like, and we tend to release dozens of times a day now. We used to release it all at once as a monolith, but now we release in multiple different common collections of services which we release, and so these will all go out as normally once a day each, which means we're doing approximately 7 releases at least a day, if not more. Now, you might ask the question, well, how does this go down with the auditors? Now, the auditors, I will admit, and regulators and other groups of people who like to look into what we're doing are a bit, did cock an eyebrow when we started explaining how we did this. But one of the things that they ask for is that we need to be able to inform everyone at the bank that a release is happening. And we do that through what's called the rolling GIF. Which is whenever we roll a release, we post a GIF of something of some sort of rolling or on the theme of rolling into a channel in Slack to let everyone know that a particular service is rolling. And that allows everyone to see what is rolling, when, where, and gives the necessary audit functionality and control that is necessary. Indeed, huge amounts of the auditing that we need to do to say who approved what, when, where are done via Slack and then saved off, so that when people come, any IT audits get performed, we can easily say, well, such and such a person approved a release. Here's the process. You can see all the stages that were being followed. This has been recorded. So that is done and recorded, so that we have that audit trail there. We have that visibility. So we still have the procedures and processes that you need, regulatorily, in order to do IT changes within a bank. But we have just pared them down to the minimum that we actually need, and then automated them so that they're really quick. And if something goes wrong, we have huge amounts of monitoring. This is a picture of a thing called an office, which back in the day, people used to go and sit in and do work in. I don't know if anybody remembers that from the before times, before COVID. But yes, this is a picture of our office where people, and the various graphs all over the place showing various metrics of things happening, and it becomes very clear when something goes wrong, because you can see this. We've also got in nowadays that we don't all have access to these big screens on the wall showing graphs. We have access. We have instead created alerts that automatically pop up when something has gone wrong, if something's down, if too many errors are being generated, that sort of thing. An alert will pop up that will allow someone to go in and check it and go, oh, is this working? Is this not working? What's going on? And that sort of thing. And if something does go wrong with a release, we can just roll it back. And we're happy with rolling it back because it's, we've got a previous image that we know that works. And to be honest, we've only put like a day's worth of work, if that, into a release. At large banks, once you've got a release that's 3 months worth of work and you want to roll it back, there are huge amounts of arguments and debates and emotions being poured into this thing, because if you want to roll it back, then you're not only rolling back your piece of work, you're rolling back 3 months of everyone else's pieces of work. And that's going to annoy them, especially if your thing has gone wrong and their thing hasn't. That's really irritating, because now they've been planning for this to go out and now you're going to delay it for another 3 months. Whereas at Starling, if something rolls back, we can deploy it tomorrow. It's no big deal. So the emotional commitment to each individual release is less, which means that the process is more resilient, more robust, because we are able to just do what's best for customers. Is it best to roll back, fix forward? Not sure. We can have a look at it on each individual situation. There is no conflict of interest there between the security and reliability and the moving fast. Because they are both in harmony with each other, thanks to the resilience of the system. We can test things, so we can test what happens when stuff goes wrong by just try and take everything down in demo. So again, more chat ops here with via Slack. We can just take things down and go turn off, which is pretty good. And you can, testing things in demo is always a good thing, but better than testing in demo is testing in production, making sure that you really are resilient. And that's when we come on to the topic of chaos engineering. As Netflix has developed their simian army to attack their own systems, take down their own servers, slow down their own servers, etc., to test that they really are resilient. And that video that you're watching is not going to stop in the middle if a server crashes, and to make sure that they can do that. So they developed that, and we took that idea and implemented it at Starling, not in such a large scale way. We don't have an army yet, but we do have, we are running chaos engineering at Starling Bank. So our production servers will occasionally just be randomly terminated by our chaos monkey in the middle of whatever that happens to be doing. And the reason we feel comfortable doing that is because we feel that the system is resilient enough to cope. And we know that if a large section of the bank goes down, that we will be able to, once we get the problem fixed and bring it up again, that the system will just carry on in the correct manner, that it'll do things at least once and at most once. And we won't need to spend months untangling misplaced payments, incorrect balances, etc., etc. So that resilience testing, the only way you're really sure that you really know that things are going to work is if you are just killing things in production, and to see if you have truly managed to minimize the impact of errors that you are experiencing. So,
sorry, Jason, we've got a couple of questions.
Yep.
So Robert has asked, can you see it? Robert's asked, what percentage of engineering time do you find invested in infrastructure and improvement compared to new feature development?
Oh, that's a good question. What percentage of time in? So it's difficult to estimate because it like fluctuates. So we get some periods where like a lot of time is being put into new features, and then time where we're doing infrastructure, a lot of just like upgrade work and that sort of thing. I would say it's probably about a third like upgrades and efficiency improvements and so on, to 2/3 new features and that sort of thing. It depends exactly what you classify as, because we could like what if we're like adding to an existing feature, but like I think it's a third just like purely technical changes under the scenes, to 2/3 customer facing stuff, let's put it like that.
Okay, cool. There's a couple more. Do you want me to go now, or do you want to?
Yeah, sure. I mean, I was just going to conclude by and then we'll jump to the questions.
Yeah, carry on, and then we can do these other questions at the end.
Sure. Yeah, absolutely. Yeah. I mean, I've basically got to the end there. So the conclusion is that you can move fast and be very reliable and secure, as reliable and secure as a bank needs to be at the same time, if you have created your system to make sure that it processes things at least once and at most once in a resilient and reliable fashion, and that you test this resilience and reliability extensively, and you don't just go, it's fine, it's probably resilient and reliable, but you actually go out and bash your own systems to make sure that they are truly ready to accept a fast-moving world in which things have to be ultra reliable. And that's that. So, more questions then.
Okay, cool.
I think everyone's just loaded all the questions into the last 2 minutes, so I think you've got quite a heavy Q&A session coming.
That's fine.
Do you want to go next, Ines, or do you want me to?
So I think
Sam's was the.
I think it's Sam. And
yeah.
Have you had any issues with infinite retry when service is struggling to cope inbound requests?
Yes. In fact, we've had instances in the past where the retry caused a sort of overflow problem, where retry from one service to another service. So if service A is contacting service B saying, can you do something, please? Service B has gone kaput for some reason. Service A keeps going, can you try this? Can you try this? Can you try this? Service B can't start back up because it's just getting bombarded with too many requests, which stops it from getting started correctly. So we had that problem. So we made a couple of corrections there. One was the exponential back off, so that the sort of infinite retry didn't flood. And the other one was the ability to pause an individual queue. So an individual work queue, which is focusing on a particular like sender payment, for example, the queue, you can pause those queues and then restart them when you have fixed whatever problem is being caused.
Cool, perfect. Hopefully that answers your question, Sam. We've got one from Alan. He's also wondering, but maybe it can be maintained with architecture that divide the work and people can roll back without worrying. Wasn't sure whether that's potentially a question or not, or maybe that was just a question to the group. Maybe you want to.
Yeah.
Just kind of wondering, because you kind of said that people kind of working and without fear of like rolling back. So you're maintaining within like people who devise an architecture and then an API for different people to have to develop their own components. That's more of my wondering.
So are people developing their own, like are different groups developing their own components? Is that what you're?
Yeah, so and other people maintaining an API that kind of keeps on developing more features and more infrastructure to be maintained. Is that?
Yeah. Yes, but this like these principles I've described are going to be at the core of everything. So yes, people will develop their own things in their own areas and that sort of thing. But these fundamental principles will be baked in at the start in every single place, basically. So there's a degree of freedom as to what people can do and differences that people can make, but this fundamental core is always going to be the same.
Cool. Question from Azam. So how many code stroke logic failures have you experienced in the last 12? And what percentage did you roll back over fix forward?
I can't remember what, how many code and logic failures we experienced. That's a difficult question. The rollback versus fix forward, I'd say it's we probably roll back about, it's not actually that much, because normally we find problems quite quickly. So rollback is probably about 30% or so versus fix forward is 70%, because it takes about the same amount of time to solve the problem. Normally we'll roll back if we're just totally stumped as to what's going on and we need more time to think, basically. If the problem is very easy, then yeah.
Cool. Andy has asked, how long is the UUID kept around? Forever. Example, backups restored badly have meant 6-month gaps in replay.
Yeah, they are kept around forever at the moment. We haven't got the we haven't got to the stage yet where we've had to archive large amounts of data. I'm sure we will get to that stage, and then we'll have to work out exactly how to deal with that. But at the moment we haven't had to do anything that means that the UID has to go away, as it were.
Cool, perfect. Comment from Matt, really cool talk, thank you. You mentioned moving to Kubernetes in order to become more cloud agnostic. I wonder whether that's solely to avoid lock-in or whether you have any crazy plans to go multi-cloud.
It's mainly to the regulators are not happy with the idea that one cloud provider is going to be providing lots and lots and lots of UK banking infrastructure. So it's mainly a regulatory thing I mean, it's partly that, but we agree with the sentiment, which is that in order to be more reliable, you need to not just rely on one cloud provider, right? The chances of an entire cloud provider going out across all regions in one area is low, very low, but it's possible. And if it does happen, we'd like to still be up and running, basically.
Question from Conan. So any particular reason to write a homegrown message broker instead of using existing ones on the market?
Yes, because we started writing the homegrown message broker back when we started as a sort of hey, this works, and we needed it to be much simpler back in the day because we had far less traffic and it needed to be far less complicated. And then as time went on, it's become more and more complicated, but it's never really gotten to the stage where we're sitting there going, you know what, it would just be easier now if we replace this with a homegrown with a market solution rather than our homegrown solution. So the homegrown solution works, it does what we need. I'm not saying we will never use a market solution, but there's just never been the strong enough impetus, basically.
Cool. What Java frameworks do you use to facilitate some of this?
So we don't use many frameworks at all, really. We like to keep things fairly vanilla. That's another aspect of reliability. We find it easier to maintain things if there aren't a lot of frameworks in place. So because we find it easier to bring people up to speed when they're new and onboarding and that sort of thing. And frameworks often are good at what they can do, but a lot of the time they will start failing when you want to do something slightly outside of what they can do. and then you will, so like the search for the universal framework that's going to be able to solve all your problems, is a fruitless one, I think. So you end up needing to employ multiple frameworks, and it becomes, it's often has less benefit than you think it will. So we like to try and keep things very simple and only use things if we can see a very clear benefit to them. So oftentimes we just use plain old vanilla Java, really, to write our backend code, which has, served us pretty well.
Alex asked, have you ever considered Lambda API-based architectures at Starling? For example, serverless framework?
Not particularly, no. No. I'm trying to work out why now, and I want to come up with an excellent answer to Alex, saying, here's exactly why Java server-based framework is better, and I'm not sure I can. No, sorry, Alex, I'm going to have to disappoint you. I don't have a good answer for why we haven't. We just haven't.
No worries. Josh has asked, how do you handle database updates or rollbacks?
So database updates, so database rollbacks are tricky. We're trying to come up with a better, if we need to do one, and we don't like it when we do, but if we need to do one, it is often a monitored manual process of someone going in and running something running something with someone looking over their shoulder, or watching carefully across the production database. But that's not a nice situation, so we try and do that as little as we possibly can. So rollbacks we try and avoid as much as we can. Updates we do through scripts, migration scripts through Flyway, which we use to handle our database upgrade scripts. They are quite well tested and fairly monitored. So a lot of eyes will be passed over it prior to release to make sure that it's not going to cause any major issues, because, as I said, that's the thing that is one of those things that can easily cause a lot of problems. If we can fix forward, we prefer to do that, and sometimes that is possible.
Next question. I feel like you're going to have to end up charging us money per question. Charles has asked, do you make use of API gateways such as Kong in your architecture?
No, we don't have that. No, again, fairly vanilla. We like keeping things fairly vanilla, and very little. We're only just starting to use Kubernetes, so yeah.
Cool. Question from Barris. What is it you really kill in production to test the resilience as part of chaos engineering?
One instance of a service or an entire service. So normally we just kill one instance of a service. Occasionally we will kill an entire instance of a service, although obviously that will cause outages and people will get, error messages, and customers will get those and so on. So we can do that. That's something we could do, but we tend not to. We are resilient in the sense that if we kill the instances and bring them back up again, that the system will carry on as normal, as if nothing had happened. It's not resilient in the sense that if we can kill all instances and no one will notice. Obviously people will notice if we kill all instances. They'll notice a removal of service. So that's a problem we try and avoid.
Do you use NoSQL database for banking apps?
No, we don't. We like SQL. We like normal, like bog standard, boring procedural databases. I'm afraid. We like those. Those are good for banking apps and so on. it's amazing how much you can get away with and do with very boring, plain, procedural SQL and Java, and so on. And there's a lot you can do with it.
Pretty much covered Henry's question then. What database types do you use? Do you kill databases?
Postgres, we're using Postgres 12, I think. And do we kill databases? We try not to. If you kill it, because all the work and information is stored in the database, if we kill the database, that effectively means nothing happens and every response is from a service is an error, because the first thing it will try and do is save something in a database to a command or get something from a database.
How many back-end developers manage the systems described?
Back-end developers, it's probably about 80 in total by now, people working on the back end specifically. We've got about 120 developers in total. Most of those are working on the back end.
Mm-hmm.
Do you do blue or green deployments?
No, not really. Our deployment pattern is more kill an instance, raise an instance. So we'll have like 3 instances of a particular, raise an instance, kill an instance, it's that direction. We'll have 3 or so instances running of a particular service, and then we'll raise one of the new version when we want to deploy, and then kill one of the old version, and then raise one of the new version, kill one of the old version, and keep doing that until there are no instances running at the old version. That's how we do deployments.
A question from Matt, another chaos question. Have you ever mimicked the effect of killing an AWS availability zone in production? If so, how and what did you learn?
We haven't tried that as far as I know. That's a very interesting test. I would like to try and do that. I predict we would learn that a lot of the system would suddenly disappear and people would be unhappy. But yes, it's an interesting question. I think that sort of thing will wait until we are more cloud agnostic and we are more multi-cloud. And then maybe, trying to kill an entire availability zone might become something that is more doable, as it were.
Do you use service mesh like Istio?
No. Sorry, it's a lot. My answer to a lot of these, do you use such and such a thing, framework, service mesh, the API gateway thing, is probably no. Again, very vanilla code.
For being able to be cloud agnostic, have you tried PaaS frameworks like Pivotal, Cloud Foundry?
I don't believe I have. No, we don't believe we have. I will note it down. Maybe that is a good idea.
Peter has said that they've found that updating the front end too can often frustrate older or less tech savvy users. Is this something that you've also encountered?
So it's something we certainly worry about, and not specifically older or less tech savvy users. Just all the users don't like endless daily changes to the UI. That's something that annoys them. So we try and schedule those in relatively spaced out, so that we don't annoy people by doing it too often.
And how do you ensure Idem potency for delivering and processing messages?
So it's the UID is the main way we ensure it. So if everything gets a UID hooked to it as soon as we can possibly hook a UID to it, and then that UID travels with it throughout the system. So if we're working out whether we've already sent a payment, or we've already processed a card message, or we've already changed an address change request, say, has been processed, or what have you. We've got the UID there, and then the first thing we will check is, have we already processed this UID? Has a UID with a payment with this UID already been sent? Has a and we'll constantly check that to make sure.
As you mentioned, the back end is released frequently. What is your opinion on testing and QA?
I'm against it. No. Testing and QA is important. We automate as much testing as we possibly can, because we want to we don't want testing in QA to slow down the release process, right? Because then it'll become the enemy of the release process. So we try and do it as quickly as possible while still maintaining huge amounts of coverage. We do some, manual QA and testing, but it's mostly it's not to verify that a release is good to go. It's more over a longer time period, right? It's more over, testing whether there are any general improvements we can make to the system and that sort of thing, whether there are any niggles that will annoy customers or other users of the system, that sort of thing. So our QA is over a more longer cycle than the sort of, is this release good to go? Is this release good to go? That we mostly rely on automated testing for.
What types of testing do you do, and do you follow TDD strictly?
We don't follow TDD strictly. We do TDD when it makes sense to do TDD. That's an interesting debate. My personal opinion is that TDD is very useful for when you are fixing bugs, but I've never found it as useful when you're creating something brand new. Like you write a test and it fails to compile. Well, yeah, anyone could have told you that. But I am acknowledge that there are different approaches to that, and some people like to follow it strictly. Types of testing we do, so unit testing, we do whole level integration tests of journeys like customer sign up, for example, things like that. We do contract testing between different services to make sure that services are, can follow the API contracts that they have with each other, and so on and so on. What sort of coverage do we try to achieve? We don't really aim at a particular level of coverage. We just go, we take a very finger in the air, what's sensible, have you tested what? It's a discussion between different engineers as to what level of testing is sensible in a particular thing. And if extra test cases need to be added, they need to be added.
I think this is the last question. How do you track each UID?
So they're always saved in the database. That's how we make sure that we track them. So whenever we generate a UID for an item, it's saved in the database, normally as a key on the table, so that it has to be unique on that table.
One more question.
Message queue, Kafka, other. No message queue. So all of the connection between all the systems is simply REST. It's simply, there's nothing else there. So all of the storage of and processing of the workload, work items, is done within the services itself, and that's done using our own queue. Queuing framework that we've created. And are the UIDs random strings or incremental IDs? They're random strings normally, so we don't need them to be incremental usually. Can't think of any case where we need them to be incremental. Is Starling hiring at the moment? I believe so, although I'm not sure we're hiring massively, but we are generally hiring. Yes.
That was my question as well, actually.
Yeah. Yes, absolutely. If you go to the Starling Bank website, there is a recruitment section. We are generally hiring, although we're not expanding, as it were. So that there isn't a huge amount of opportunity, but there is some. We have, when we go back to the office, we have an office at either side of the southwest. So you could either go southeast from the southwest down to Southampton, or you can go northwest from the southwest up to Cardiff. One of the two. That's where our two offices in that area are located.
Back to some questions. Do you generate UID in the front end?
Sometimes. We tried, if we can, but we try and generate as quickly as possible. Let's put it like that.
And have you found a safe and truly transactional way of generating UID on wide scale? What part of the system does it ensure global uniqueness?
We've never found clashing UIDs yet. So again, that's not a problem that we currently have. So like absolutely 100% guaranteeing uniqueness we can't do with our current setup of UIDs. But I don't think we need, like, I think it's got enough 9s that we're happy with it. How do you know you haven't found a UID conflict? We don't. But you know, that will be because the tables have the UIDs on them, and the tables are constrain themselves to only accept unique UIDs. If a UID is generated twice for a particular entity, and it only really matters if it's generated for a particular entity rather than, you know, if like a person has the same UID as a payment, that's not really going to affect us. It's more if a person has the same UID as another person. That's the problem. But then the table will, you know, the database table will prevent that. And if it's not in the database table, then from our point of view, it doesn't really count. How do you deal with third-party systems that do not follow your principles? We try and replace them as quickly as possible. Generally speaking, you know, that doesn't always work. There are some that we can't. The direct debit system, for example, darn it, does not follow our principles, and we can't replace it. But we try as much as we can to generate some sort of uniqueness constraint for it.
Any opinions on versioning REST endpoints?
Yeah, generally speaking, we try and we try and do upgrades as little as possible on our REST endpoints where we're not in control of both ends. So if we're in control of both ends, it doesn't really matter. But if we're not in control of both ends, then we need to be careful, and we will do, you know, we will version upgrade slowly. And we generally only do it if there's a big breaking change that we need to make because we've totally reimagined the system.
Wouldn't incremental generation ensure uniqueness every time a new customer is onboarded or a new payment ID is generated?
Yes. Well, depends how you're doing it. I mean, yes, if you only had one instance, but how would you ensure it if you had multiple instances, both of which tried to generate UIDs in a sequential manner? I'm not sure you could do that. And why would it be worth it? I think that I think the problem is, Adrian, you're trying to get from 99 point a huge number of 9s to 100, and I don't really care about that tiny gap. In a monolith, you're right, it would work, but we're not a monolith. Yes, and Art makes another good point as well, is that deterministic IDs can be a bit of a problem. Randomness ensures a degree of an extra degree of security, an extra layer of security, should we say. Cool. Well, hopefully I've got through all the questions.
Yeah, that was amazing. And yeah, I hope we all agree that was a really good talk. Thanks again, Jason. That was really good. Even for someone that is not any remotely technical, like myself, I understood some of it as well. So, so that's massive kudos to you. And yeah, we've got our meetup next month, probably around this time of the month again, around the end of the month with Citibank. One of the development managers giving us a talk there. So carrying on the theme of the sort of banking some element from today. Be any sort of closing words from yourself?
No, I don't think so. Just a massive thank you, Jason. That was really enjoyable. And yeah, I agree with Innes that even I managed to follow most of that, which makes a change. So no, it was really good. If if anyone on here is interested in doing a talk, feel free to reach out to myself or Ines. We're always on the lookout for more people. And yeah, same time, same place next month.
Perfect. The recording should be out in, I think, a few days time. So
yeah,
cool.
Perfect. Thanks a lot again.